So in my previous job, I used to work in implementing genomics and breeding technologies for aquaculture species. And that involved a lot of work in trying to make the technologies feasible economically. And then that's where a lot of our work with the AgriSeq and Axiom platforms happened. In a lot of livestock species, because the value of the animals is so high, genomic selection is done using arrays directly, high-density arrays like Axiom. Because in aquaculture, the value per animal is so low, we have to try to reduce the genotyping cost per individual. And so our process always has been, if there is a high-density Axiom for the species, we'll start with that, try to characterize the population and which one of the SNPs are variable in that population. From there, we'll extract around 60,000 SNPs, making sure that there is enough coverage of the genome. And to lower the price of the array part, we'll do a 50K 384. And from the 50K 384, then we move that into a 2,000 to 3,000 AgriSeq panel that is used for imputation. And so that we can lower the cost, and that's really where the combination of the two platforms has been very powerful. This platform really is the only way to implement genomic selection in a feasible way in aquaculture. Unless you have very high volumes, you're not going to get to that price point. And so we were working previously very hard in trying to find a genotyping platform that was on the thousands to implement this kind of approach. You know, we had low densities through PCR, and we had high densities, but we had nothing in the middle that were between 1,000 and 5,000 SNPs. And really being able to genotype 3,000 SNPs at a lower cost, it's what enables you to apply this technology and genomic selection to aquaculture species, especially when you're talking about emerging species that don't have the same resources as Atlantic salmon, let's say. One of the things that when we went into this, that we were not really concerned about Axiom. Axiom has a track record, and the array was validated before by other groups. But we were a little concerned about how the AgriSeq platform would perform, because some aquatic animals have very complex genomes, pseudotetraploid genomes. And so we were a little concerned about mapping problems and calling errors. And to our pleasant surprise, we developed a couple of panels in a very complex genome that worked really well. And I mean, the designs were fine, and a lot of them just worked. That was a good experience. And I mean, the group at Austin is really helpful, and they helped us through the bioinformatics of it. And our genome was too big to use the web platform to do the design, so Thermo did the designs in-house for us. It was a good experience. So now I'm working with shellfish, and it falls exactly into that in emerging species and lowest value possible. So shellfish usually, especially mussels, have a very low value per individual. And we want to take this to the extremes now, where we're going to sequence the genome and then develop AgriSeq panels, but probably much smaller at the thousands or even at the 500 level, and see if we can implement a genomic selection based on that. So it's not going to be as great as a good panel, but we want to try to find where is that spot where you still get an advantage from genomic selection versus traditional selection. And so that's the future where we're going to go in. And that's the thing, in aquaculture, we're going to always be pushing for the least cost per genotype possible.